Hello everyone. Let's look at the chapter Circles from class 9. Now, the name of the chapter is circles. Do we know what circles mean? Can we define circles? Circle is nothing but a set of points. Circle is a set of points. What is the condition on the points? That these points are placed at a fixed distance or at equal distance from a fixed point. So we can say a circle is a set of points whose distance from this fixed point is same. It is a set of points whose distance from a fixed point is equal. The fixed point is called as the center of the circle, and these points are on the circle. The distance between the center and any point on the circle, for that matter, you can take any point on the circle, is going to be called as the radius of the circle. Is the radius of the circle. So what do we say? O is the center, and if I call this point as A, then OA is the radius of the circle. OA is the radius of the circle. What about this point? If I call A, B, C, D, then OB is the radius, OC is the radius, OD is the radius. And what do we know? All these points are at equal distance from O. That means OA is equals to OC is equals to OB is equals to OD. Is the definition clear? What is the definition of a circle? It is a set of points that are equidistant from the fixed point. The fixed point is called as the center of the circle. Now this circle, if we consider a circle in a plane, if we consider a circle in a plane, suppose if I consider this to be the plane that we are considering, and inside the plane is a circle. Inside the plane is a circle. The circle has divided the plane into how many regions, children? Very good. The circle divides the plane into three regions. Interior of the circle, exterior of the circle, and on the circle. So it divides it into three parts, right? Next, if we look at the definition of it, like the terminologies, the different terminologies, then we know in a circle, if we have a circle, say O is the center of the circle. Children, the circle isn't perfect, but I hope you'll assume it to be. O is the center of the circle. If I take any 2 points on the circle, if I join O to A, radius, O to B, radius, but if I join A to B, we are taking any two distinct points. Why am I using the word distinct? Because if I take C over here and my D coincides with it, then are they distinct? No, they are not. That is why we are considering two distinct points A and B. The line segment which joins these two distinct points A and B that are lying on the circle is called as the chord of the circle. Is called as the chord of the circle. We can have many chords, right? This is a chord. We can call this as the chord. Any 2 points you take on the circle, a line segment which will join it is called as the chord. What about a chord which is passing through the center of the circle? Can we have a chord which is passing through the center of the circle, say PQ? Or say we have another chord which will pass through the center, say MN. So the line is not straight, but I hope you're understanding the concept. Okay. So what are these chords called? Even they are chords, but since they are passing through the center, they are the longest chord. What is it called? It becomes the longest chord of the circle, right? This longest chord is called as the diameter of the circle. So what is diameter basically? It's a chord and it is the longest chord. If I look at the diameter part, we see it is made up of two parts and both of them are called as the, very good, they are called as the radii. So we have radius and radius. So we can say diameter is nothing but 2 times radius. Am I understood? Further moving on, if this is a circle again, how many chords can be drawn to a circle? A circle with center O, how many chords can be drawn? We can have infinite chords. We are not even talking about the length. We are just talking as to how many chords can be drawn. You can draw how many ever chords you want. Am I right? So how many chords can be drawn to a circle? Infinite. What about modifying the question and asking you, How many equal chords can be drawn? When are two chords said to be equal? If their length is equal, because it is a line segment, we can measure it, right? So if the line segment or if the chord is of equal length, they are called as equal chords. Suppose if I have a chord AB, I have another chord say CD, and we are saying that both are equal. Now you need to tell me how many equal chords are there. Again, we can say there will be infinite chords which will have the same length. Am I right? So again, we understand there are infinite. How many diameters do we have? Again, we have infinite because through the center, there could be many diameters that could be passing. We can have many line segments which are passing through the given center of the circle, right? Next term that we understand over here is an arc. What is an arc? Arc is a part of the boundary or the circumference. What is arc? Part of the boundary or the circumference. Okay. It is not, it could be the complete circle also, but we are looking at part of it. If we call the endpoints of the arc as A and B, we can write this as either arc AB or arc AB. These are the two representations. What is the arc part of? The arc is part of the boundary. Boundary means circumference, right? In the same arc, if I join the endpoints A and B, what do I get? Correct? It is called as the chord. It will be called as the chord AB. Suppose if I join the endpoints of the arc to the center of the circle, what is this called? This is called as the sector of the circle. It is called as the sector of the circle. Now, if you look at the sector, it is less than the semicircle. Every diameter divides a circle into two parts. Each is called as a semicircle. And if you look at this sector that we have drawn over here, sector AOB, it is less than that of the semicircle because semicircle circle would be the whole of this. And our shaded region isn't a part of, is just a part of it. It is not the whole. It is less than it. So it is called as the minor sector. Whereas if I look at this part, if I look at this shaded region, I hope you're getting it. Since this is more than the semicircle, it is more than the dotted line, the diameter that is given to us. Am I right? So then that is called as the major sector. What is this called? This will be called as the major sector. Likewise, if you look at this arm, which arm are we talking about? We are talking about this arc. Arc A to B. Arc A to B. This entire thing. Talking about this arc. I hope you're understanding. What is this? This is more than 180. So it will be called as the major arc. It will be called as the major arc. And this will be called as the minor arc. The region that is enclosed by the radii and the corresponding arc is called as the sector. What kind of a sector is this? This again is a minor sector, right? Moving ahead. So what are the terms that we've come across? We understood what is center, but before understanding, we understood what is a circle, radius, diameter, chord, arc, sector, right? Now let's look at one more term. In a circle, the region, if this is the center of the circle and I take an arc AB, okay? If we join the endpoints of the arc to the center, what do we get? We are getting an angle. So this is called as the angle subtended. Angle subtended by the arc at the center of the circle. At the center of the circle. Now circle, how to note? Triangles we write like this, quadrilaterals we write like this, circle we write like this. Okay? Now, okay. If we write triangle ABC, we write quadrilateral ABCD. What about the circle? Circle will be written as notation center of the circle. First we will write center, comma, radius. Means if I want to mention write this circle, I'll write circle with center O and radius. What is the radius? OA is one radius and OB is one radius. Whichever we want, we can take. If you want to write OA, that is also okay. Or if you want to write a circle with center O and radius OB, that is also fine. Right? Now over here, what is the keyword that we have to highlight? Subtended. The keyword that is to be remembered over here is subtended. Arc AB is subtending an angle AOB at the center of the circle. Arc AB subtends an angle AOB at the center of the circle. I hope it is understood. So we've come across another word called as subtend. Subtend. Moving ahead. Now, if we know in a circle, the line segment which joins the center to any point on the circle is called as the radius of the circle. Okay, correct? Now, we need to understand again. If I have a circle with center O, and if I ask you to plot any point in the plane, any point in the plane. So, there are only three possibilities, children. We have a point A over here, or B over here, or a C over here. Means what? In the first case, when I join OA is little less than the radius. Why less than the radius? Because radius would be a line joining a point on the circle to the center. Now, it is midway. A is somewhere here, so it is going to be less than the radius. Am I right? If OA is less than the radius, then what is the location of A? A lies inside the circle. So looking at the distance of a point from the center, we can also find out its location. We calculated OA and we told OA is less than the radius. So we are saying that A lies inside the circle. So A lies inside the circle. What if I have OB where B is lying on the circle? Where B is lying on the circle, that means it is a radius. So we say that B lies on the circle. And the third case I'm telling you that OC is greater than the radius. Radius is only till here. It is going beyond. Radius was only till here. But it is going beyond, so definitely greater than radius. And because it is greater than the radius, we say that C lies outside the circle. Right? Outside the circle. I hope you all have understood these terms. In the next video, we are going to see the theorems that are associated with this chapter. Right? I hope everyone has understood these terms. Thank you so much.